The sixth question, yes. Okay. Let's do the sixth one. The lengths of two, can you please read the question, Hiba?
Yeah. The lengths of two sides of a triangle are 12 centimeter and 15 centimeter. Between what two measures should the length of the third side fall?
Right. Okay. So let's think about it. So there's a triangle. One side is 12 centimeter and the other side is 15 centimeter, right?
Yeah.
Between what two measures should the length of the third side fall? The third side, whatever it is, let's say it is x, okay? We know that the sum of any two sides should be greater than the third side. So 12 plus x should be greater than 15. Right? 12 plus x should be greater than 15. And then 15 plus x should be greater than 12. Well, that's not going to be a problem for us because 15 plus anything, any positive number, 15 plus any positive number is obviously going to be greater than 12 because 15 itself is greater than 12, right? So no matter what you add to this, whether you add 1 or 2 or 3, whether x is 1 or 2 or 3 or whatever it is, one number is already greater than 12. So the whole thing is going to be greater than 12. Is this much clear?
Yeah.
Yeah. So this is not going to be a problem for us. The problem is going to be this thing, that 12 plus x should be greater than 15. And the second part, or rather the third part, which is the third part? 12 plus 15 should be greater than x. Okay?
Okay.
Okay. Now that means what we can do here is you take 12 to the right hand side. Okay? You bring 12 to the right hand side like the transposition method. So how do you do it in an equation? Let's say, for example, if this was an equation where 12 plus x is equal to 15. In that case, you will say, okay, I am taking 12 to the other side. So it will become x is equal to 15 minus 12, right?
Yeah.
Because 12 is going to the other side. Transposition method, clear?
Yeah.
Yeah. But here you don't have equal to sign. You have which sign here?
Like greater.
Greater than sign. Very good. So 12 plus x is greater than 15. So nothing different. Just you have to replace the equal to sign with the greater than sign. Okay. So 12 plus x is greater than 15. You take 12 to the other side of the equation. So it becomes x is greater than, because greater than sign. Okay. Nothing. We're not changing anything about that. So greater than 15 minus 12. The only thing we've done is taken 12 to the other side. Yes, Iba?
Instead of 12 plus x is greater than 15, can we also use 15 plus x is greater than 12?
That's what we did here. See, 15 plus x is greater than 12. But this is not really going to be very helpful because 15 plus anything is greater than 12, Hiba. Right?
Yeah.
Any natural number, because the sides of a triangle, can they be negative?
No.
No, they're going to be positive only. So this x has to be a positive number. And now imagine whatever positive number you add over here, right? Whatever positive number you put in place of x. 15 plus 1, that is 16, greater than 12. 15 plus 2, 17, greater than 12. 15 plus any positive number is going to be greater than 12. Why? Because you are saying 15 plus something greater than 12. Yes, obviously it will be greater because 15 itself is greater than 12. So no matter what you add to it, the resultant is going to be greater than 12. Getting it?
Yes.
So that's why we didn't take this one, because it's not going to be very helpful for us.
Okay.
Understood?
Yeah.
Okay.
So,
Hiba, your voice is breaking for me.
can you hear me now?
Yeah, I can hear you. Just try to speak up like a little louder. Okay. You're fine now. So is this thing clear, Hiba?
Yes.
Good. So that means x should be greater than how much? What is 15 minus 12?
3.
3. So that means x should be greater than 3. So this is one hint that we have found. Let's keep it, let's save it somewhere and keep it. Okay, let's not forget this. So that's why I have put it inside a box. Let's remove all the other boxes. Fine. Now the other thing that we were looking at was, so we saw this one, we saw this thing, 12 plus x is greater than 15. We saw it and we solved it. Okay, now the next part is 12 plus 15 should be greater than x. Let's try to solve it together.
Okay.
Okay, so 12 plus 15 is greater than x. What is 12 plus 15?
It will be 27.
27. So 27 is greater than x. Now, Hiba, tell me one thing. If I say 3 is greater than 2, or if I just flip the whole thing and I say 2 is less than 3, is it the same thing or different?
Same thing.
Same thing, right? So what I have done is I have just flipped the sides. I have flipped the sides and changed this sign over here. Right?
Yeah.
No difficulty, no problem.
Yeah.
Okay. So the same thing we're going to do here. 27 is greater than x. That means x is less than 27.
Yeah.
Yeah. So between what two values should the value of x lie? X should be a number. Let's try to understand this using a number line. X, one sec, it's problematic. So x should be a number which is greater than 3 but less than 27.
T will be the side.
Are you understanding?
Yeah.
So this x can be anything. We are not defining it. We're not saying that, no, it has to be this particular number. No, it can be any number from 3 to 27. Actually, no, between 3 and 27. Okay. So Hiba, you pick up any number between 3 and 27.
11.
Very good. Just a minute. Okay, so you said 11, right? Okay, let's take 11. Let's say this, we have a triangle 12, 15 and 11. So 12 as it is, 15 as it is, and you said x, let's try to keep it 11. Will it be possible? Let's try 12 plus 11. Is it greater than 15?
Yes.
Yes, 23 is greater than 15. 12 plus 15, is it greater than 11?
Yes.
Yes. 15 plus 11, is it greater than 12?
Yes.
Yes. So any number between 3 and 27, when you choose, it will give you a proper triangle. Okay, any number for x. Got it?
Yeah. So the two sides of the triangle should be bigger or smaller than the other side.
The sum of the two sides of the sum of any two sides of a triangle is always greater than the third side. The sum of two sides, this plus this, should be greater than this.
Okay, understood.
Very good. Now let's look at the next question. Okay, so this thing is over.
Actually, I didn't complete the fifth one.
You want to write it?
No, I didn't complete the fifth question in this exercise.
You didn't complete the
Fifth question.
fifth question. Okay. Hiba, how about we come to the fifth question in a little while? Like we'll come to that after we have done the next portion. Okay, because I want to complete the next portion very quickly.
Okay.
Okay, because that is a very important part.
Okay, we can do
Okay,
that.
so once there was like long ago in Greece, there was a mathematician called Pythagoras. Okay, and he was a very brilliant person because obviously he was a mathematician, and he was a philosopher, a physicist, and all those things. So Pythagoras, he figured out that if you have a right angled triangle, okay, you have a right angled triangle, then what is going to be the relationship between the three sides of the triangle? He said that if you take the three sides of this triangle, okay, so that in a triangle, he said, in the triangle, so in a right angle triangle, actually, this is the right angle, right? So the side which is opposite to the right angle is called the hypotenuse. What is it called?
Hypotenuse.
Okay, you better write it down before you forget, right? Hypotenuse.
Okay, I wrote.
Okay, this is the hypotenuse, and these two are the perpendicular sides. Perpendicular means 90 degrees, right? So this purple and the orange side are perpendicular to each other. Okay. Now, Pythagoras gave something which is called a Pythagoras theorem because he observed it that the sum of the smaller two sides, the perpendicular sides, in fact, the sum of the squares of these two sides is going to be, don't get confused on what I'm saying. I'm going to explain it. So the sum of the squares of these two sides is going to be equal to the square of the third side. What does that mean? That means that, let's say, whatever this is, let's say this is equal to A, okay? From here to here, the length is A. From here to here, the length is B. And from here to here, the length is C. Okay. Then Pythagoras theorem states that A square plus B square gives you C square. Okay. And if you say how, and then this is going to require an activity, which let me try if I can show you the activity, but it's something that you will only understand if you do it hands-on. Okay. Let me try to show it to you though. Wait a minute. Just a minute. Okay. All right. I'm going to share my screen. Can you see this?
Yeah.
Okay, don't focus on the squares right now. The squares are secondary. The triangle is the primary thing that we're talking about. Look at this side of the triangle, the vertical one. What is the length of this side?
Which one?
The vertical side. Can you see my cursor?
Yeah.
The vertical side.
34.
What's the length of the side, bacha? This one, the red side.
39.
No, that's not the length of the side. Dekho, don't look at the area. We're not talking about the area. We're talking about the length of the side. What does that mean? That, okay, wait, let me just see if I can, okay, I can do this. So I can use the annotate tool here.
How do we find the length?
Yeah, I'm telling you. Just a minute. I'll have to switch off. One sec. Okay. Huh. So you can see this one, right? So from here to here, this is 1 unit. From here to here, right? Then from here to here again, this is another unit, so 2 units. Then from here to here, 3 units. So the length of this, the whole thing from here to here, this is 1, 2, 3 units. So the length of this side is 3 units. Understood?
Can you show how to find the length again?
Hiba, can you see these squares? Can you see these squares, the dotted squares?
Yeah.
Okay. If I say I am drawing something from here to, let's say here. I'm sorry about that. Let's say I'm drawing something from here to here. Can you tell me what is the length of this without, we're not talking about the accurate length. We're not talking about the length in centimeters or anything. Just
4.
Yes, very good. Because it's covering 4 units, right? 1, then the second unit, then third unit, then the fourth unit. Unit means square or block. So the length of this total thing is 4 units. So similarly, the length of this side of the triangle. See, here we are only talking about a triangle and not anything else. Just a minute. So this is the red side. This is the green side. And the blue side is, as shown, is over here. Okay. Can you tell me this length of the red side now?
4.
Bache, can you please count it once again? Like, see very closely. If you want, you can zoom in.
3.
Yes, very good. Because this is 1 block, 2 blocks, and 3 blocks. So the length is 3 units. So the length.
But the first one is like only half.
No. It's full, Hiba. It's full. Zoom in. Zoom in. It is starting from here. See very carefully. This is 1 square. This is another square.
Okay, understood.
Got it? Very good. So the length of this side is how much?
3.
3 units. What is the length of the green side?
5. 5 units.
Very good. It is 5 units. What is the length of the, okay, now you won't be able to measure the length of the blue side because it's diagonal. Okay, so you can't measure that. Okay. Let me do this. This one, let me change it. One second. Okay. Okay. So once again, the red thing is as it is. It is 3 only. What I changed the green side. Can you tell me the length of the green side?
4 units.
4 units. Okay. Now, how do we find the length of the third side? Because you can't see, Hiba, this thing is 1 unit, right? And here also it is 1 unit. But if I want to find what is the diagonal, what is the distance between their diagonals, how will you find it? You can't say it is 1. Why is it not 1? Because clearly it is greater than 1. Right?
Yeah.
It's greater than 1, but it is less than 2. Right?
Yeah, I understood.
Yeah. So to find this, to find that, okay, what is this diagonal side? We should have a formula to find out the length of the diagonal side. So to do that, diagonal side means hypotenuse. So to do that, we have the Pythagoras theorem, and this is what it says. So Hiba, now it's time to focus on these squares. So now imagine that there are these squares that are attached to each of the sides. Okay. Now Hiba, just focus only on the red square for now. Okay.
Okay.
What is the length of the side of the square?
3.
Yes. So the side is 3 units. So Hiba, if you have a square whose side is, let's say, whatever it is, let's say it is A, you have a square, the side is A. What is the area of the square? Formula for area of the square is?
A multiplied by
Very
the
good. A
area.
multiplied by? It is A squared, right Hiba?
Yeah.
A squared. And think about it like this. A is the side of a square. So A squared. Okay?
Okay, understood.
Okay. So the area of a square is the side square. So what is the area of the red square? 3 squared, right?
Yeah, but
What
it
is
is
3
9.
squared? What is square, Hiba? Square means 3 into 3. 3 square means 3 into 3. 5 square means 5 into 5. 7
So
square means 7 into 7.
3 square means 3 into 3.
Yes, very good. 3 into 3 is
9.
9. So the area of the red square is 9. Okay.
9.
Now, what is the area of the green square?
Of 4 into 4.
Very good. 4 into 4. And what is 4 into 4?
16.
16. So that's why they've written 16 over here. Now what this person did, he counted or he calculated the area of the blue square. We don't know the side, right? We don't know the side. But it turns out that when you add 9 and 16, please add 9 and 16 and tell me what you're getting.
25.
Very good. So Hiba, how will you calculate the area? How do you calculate the area? Calculation of area when you have a grid form, like over here you have a grid in the background, right? There's small squares everywhere. So the way to calculate it is, okay, let's try calculating the area of the green square. Okay, what you have to do in that is you have okay, 1 square, so 2 squares, 3 squares. I'm just counting the number of squares inside the green square. Okay.
Okay.
3 squares, 4 squares, similarly 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is why we say that the area is 16 square units. Okay.
Okay, I understood.
Good. So can you find the area of the blue square using the same method that I just told you?
Yeah. So will it
See,
be 5
first what you
squares?
have to do is find what all areas, what all squares are complete. So this is one whole square, one square, two. We are seeing the squares which are completely inside the thing. You won't count this one, for example. You won't count this one. Why? Because
Because
part of
it's
it is inside and part of it is outside.
yeah.
Good. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then 9, 10.
13.
Sorry.
There are 13 squares.
13. One sec. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 squares which are completely inside the region. Okay, now the rest of them we have to see how to fit, where to fit what. Okay. So this square, this one, okay, the one that I'm coloring, and this square, they can fit in with each other. If you
Yes.
take this and flip it over and fit it over here in this portion, it will fit, right?
Yeah.
So that gives us 13 plus 1, 14. Okay. We had 13 to start with. Then we have 1, which is 14. Then this thing, you can fit in this one, the tiny piece that is left over here, this one.
Yeah. That will be 15.
Very good. So 15. Next, let's take this. Okay. We've done with 15. Okay. So we're taking this. This, you can compile it with, you can combine it with this one. See?
Yeah, we can just flip it over.
Yeah. So these two will fit in with each other. So 15 plus 1, 16. Okay. 16. Then similarly, this plus this, these two on the left, 17.
17.
Good. Then this thing with this thing, the one on the right, 18.
Okay. And
Good. Now this one with this one, if you see carefully, okay, 19. Understanding, Hiba?
yeah.
Okay, 19 done. So the next one is this thing. Look at this and this. Yeah, this one. 20.
Yeah.
Then this thing plus the small portion over here. 21.
21.
Fine.
Yeah.
Then similarly, this thing with this small portion over here. 22.
Yeah.
Then next, this with this. 23.
Yeah.
Then this one with this one. 24.
Yeah.
And then finally, this one and this small thing over here. 25. So
Yeah.
in total, how many squares are there?
25.
So what is the area of the blue square? The big blue square?
25.
Very good. So the area of the big blue square is 25 square units. Now, Hiba, if you have a square whose area is 25, then what is going to be the side of that square?
Can you repeat the question again?
If you have a square whose area is 25 square units, what will be the side of that square?
25 square.
No. Area is 25. See here, for example, in the red square, the area is 9, the side is 3, right?
It
So
would be
what is
5.
the relation? Side into side gives you the area. So just think about it. What into what gives you 25?
5.
Very
5
good.
into
So that means the side is how much?
5.
5. So that means I'm going to erase all of this. That means this blue square that we have. What is the side of this blue square? The length of the side?
5.
5 units. Okay.
Okay.
So what did we see here? That the side, this side ka square. Okay, 3 ka square kya tha? 9, right? Let me not confuse you with the different colors. So 3 square, which is, or let me write it like this. 9 plus 16 okay. Let me, one sec. Okay. Oh no. One second. Okay. So 9 plus 16 gives you
25.
25. And what is 9? It is the square of
3.
3. Very good. And what is 16?
4 square.
4 squared. Very good. And what is 25?
5 square.
5 squared. So we see that if you have, and no, it doesn't matter which kind of triangle it, not kind of triangle, it is only for a right angle triangle. So it doesn't matter which, what is the length of the sides, this formula is always going to be the same. What is the formula? That a square, and this has to be these two sides. Okay, the a is this side, these two perpendicular sides, b is this side, and c is the hypotenuse. C is the hypotenuse. Always remember, the sum of the sides of the perpendicular is equal to the hypotenuse square. Always, the hypotenuse square is always going to be on the right hand side. It's going to be alone, because the hypotenuse is always greater than, well, each of these is going to be greater than, but the hypotenuse is, or you can say the hypotenuse square is equal to the sum of the squares of two perpendicular sides. Is that okay?
Yeah.
So let me just show you. If you change this, okay. Okay. This can't move or what? Oh, it can. Ooh. It's not coming to the exact, just a second, Hiba. Or we can just do 60 to 10. Yeah. Okay. Hiba, now can you see एक second. Yeah. Now can you see it? Huh. So can you tell me what is the side, the red side, the length of the red side?
6.
Very good. So this one is 6 units. Green side?
8.
8 units. Very good. So you see 6 square. So if you
Yeah.
want to find out the length of the hypotenuse, what do you have to do? You have to do 6 squared plus, yes, Hiba?
6 squares plus
6
8
squared
squares.
plus 8 squared. Very good. And that is going to give you
100.
the hypotenuse square. Okay. Yeah, it is 100, but let's say the hypotenuse is x. Fine. It's going to give you
Okay.
the hypotenuse squared. So 6 square is how much?
36.
Very good. And 8 eights are
60, 64,
yes. And what is 36 plus 64?
100.
Is equal to 100. So that means your x square is equal to 100. Okay. X square is equal to 100.
100.
So now you will ask yourself, well, which number do I have whose square is 100? Yes, Eba?
Um,
That means
10 multiplied by 10.
very good, Hiba. Excellent. 10 multiplied by 10 gives you 100. So
10 square.
now you know that the third side is how much?
10 square.
Not square. The area is 10 square. But the third side is 10. Right? If if one side of a triangle is of a square is 10, that means every side is 10, right?
Yeah.
So that then the area becomes 100.
Yeah, I understood now.
So the side is how much once again?
10.
10. Very good. So Hiba, again, let's say, just a minute. Now let me just go back to the textbook. Okay. So let's say if you have a triangle, a right angle triangle, just remember that for the Pythagoras theorem, you need to have a right angled triangle. Okay.
Okay.
This won't work if you have any other type of triangle. Okay. So let's say you have a right angled triangle where one side is 5 centimeters. The other perpendicular side is 12 centimeters. No, wait. Can you tell me what will be the hypotenuse? How will we solve this, bache?
How do you find the hypotenuse?
Yes, just now we had done this. What did we do? 5 square plus
12 square gives x square.
very good. 5 square plus 12 square gives x squared. Now what is 5 squared, bache?
5 multiplied by 5, so it will be 25
Very
plus
good. Plus
12
12
100.
12s are
114.
144. Then it is equal to x squared. Okay. Now, what is 25 plus 144? Let's try to solve it. Solve it and tell me what is 25 plus 144?
Okay. 169.
Very good, 169. So 169, so what does that mean? X squared is equal to 169. So can you tell me which number multiplied by which number? Or you can say which number's square is 169? Okay, see, Hiba, for this you will need to memorize the squares till 30. Okay, can you do that for me?
Okay.
So this is your homework. You have to memorize the squares till 30. What does that mean? That means 2 square is 4, 3 square is 9, 4 square is 16. Okay, all the way up till 30, you have to memorize it.
Okay, I will do that.
Inshallah. So in the next class, I will randomly ask you from anywhere, what is the square of, let's say, 15? So you should be able to tell me the answer. Okay.
Okay.
So, or I can ask you the other way around as well. What is the square of, square root, by the way, this is called a root. What is the square root of 196, for example? Then you will say 14.
Okay, okay.
Okay, very good. So 13 square is 169. So here x will be 169. I'm sorry, x will be 13. If you want, you can check it out by yourself. 13 13s are 169. Okay, ba?
Okay, understood.
See, I will tell you one short trick to find out if you can't remember the if you can't remember the squares, then there's a trick. Okay, you have to just remember a few basic squares. Just a sec. You have to just remember a few basic squares. What are those? 5 5s are
25.
25. Very good. 10 10s are
100.
20 into 20.
40.
Yes, Iba?
40.
40. But 20 into 2 is 40. Okay. 20 into 20. How will you solve it? You will just say, okay, 2 2s are 4. How many zeros are remaining?
2, so 400.
400. Okay. So 2020s are 400. Okay. This is one thing that you need to remember. And the third one is obviously 30 square is 900. Now you will, let's say you get something. If I give you a number, let's say 576. Okay. You know that 576 lies somewhere between this and this.
Yeah.
So 576 will be here. That means your number will lie, your square root will be between 20 and 30.
Yeah.
Yes. Now, what are you going to do? Are you going to sit and solve every single thing? 21 square, 22 square? No. You will act smart and you will look at the last digit. The last digit is 6. Okay.
Okay, understood.
Now, Hiba, if you have, let's say if it is 21 square, that means 21 into 21. That is going to, I'm not going to sit and calculate it. That is going to give me a number whose last digit is what, Hiba?
6.
See, do this. 21 multiplied by 21. Okay. if you multiply them, 1 ones are 1 and whatever the rest of it is, okay, 1 to the whatever. Over here, you're going to put a cross, or if you put a 0, that depends from person to person, but the last digit is going to be what? Of whatever this number is, the last digit is?
6.
Yes, Hiba?
6.
Hiba, your voice is breaking, bache.
6.
Hello.
6.
Your voice is like breaking a lot. I can't hear you.
Can you hear me now?
Yeah, now I can hear you. Huh. So what is the last digit?
6.
What?
6.
Bache, the last digit of this 21, if you multiply 21 multiplied by 21, what is the last digit?
1.
1. Because 1 into 1 is 1. Similarly, let's say, okay, do one thing. Multiply 19 with 19. And the last digit is going to be 1. Do it. Tell me the final answer.
Okay. Th- 361.
Last digit is 1, right? Now do
Yeah.
one thing. Multiply 29 by 29.
841.
Okay. So again, the last digit is
1.
1. Why is that happening, Hiba? Because 9 nines are 81. What is the last digit in 81?
1.
1. So no matter what the tens digit is, no matter what this digit is, it is 9 nines are 81, right? So this last digit is always going to be 1. Similarly, if you have any number that ends with 6, like 6 square, that is 36. 16 square, that is 276. Is it, sorry, I think it's 256. Okay. If you have 26 square, that is 576. Okay. So why is this happening? Because 6 square is 36 and the last digit is 6. So that's why this is happening. So just make a list of these things. 1 square is
1.
1. 2 square is
4.
4. 3 square is
6.
9. Bache. 3 threes are 9.
Sorry, 9.
4 squared is
16.
16. So I'm not going to focus on 1 right now. I'm going to focus on 16. Okay. I'm sorry. I'm going to focus on the digit 6. Now 5 square is
25.
25. 6 squared is
36.
very good. 7 squared is
42.
49.
Yes.
Okay. 7 sevens are 49. 8 squared
64.
64. 9 squared
81.
81. And 10 squared
100.
100. So if you're having in your hypotenuse or on the right hand side of this equation over here, this one, okay, over here it's coming as 169, right? And over here, where did it go? Okay, I don't know where it went. So whatever it is, we were talking about this number 576. So 576